So I will leave the floor to Emrah. So he will be our,
showrunner for
this track. So, floor is yours.
Thank you, and thanks again everyone coming here. So I'm super excited. Like he was doing this all over the years. So this will be my first time here. So I think I am getting promoted a bit. So and I'm not the. I'm like very happy to introduce our keynote speaker. So Usman Khalid, he's the AWS head of AWS Serverless Compute, and he came all the way from Vancouver to here for his talk. Like when we first, I don't know if I am allowed to say this, but anyways, when we first invite him to be our keynote speaker, he was head of AWS Lambda only, and like. As I promoted, he also got promoted to head of all AWS Lambda, AWS Serverless Compute, and like congrats for both of us, I guess. So yeah, and he will be now going with his talk. Usman.
Should we try again? There we go, much better. Woohoo! So I think we worked through some technical gremlins right now. Folks, marhaba, welcome. Thank you so much for coming to the talk, and thank you to Emrah and Serhat for organizing, and the rest of the organizers for organizing the talk. I'm super excited to be here. This is not my first time keynoting one of these days, but I am trying to do something different this time as I do this talk. And normally what I do is I talk about technology trends, I talk about what I see customers doing with AWS, what are some of the bigger topics with serverless. I've been with AWS for almost 12 years, now it'll be 12 years later this year, and I've been with the serverless space since somewhere around 2019, 2020. I launched the EventBridge service, and I also own the Step Function service as well. But I've built a ton of products in AWS all the way for some of our infrastructure services like auto-scaling as well. So super excited to be here. First time in Istanbul for me as well, and so it's been very excited to visit. Okay, so let's get started. And so and it's obviously an AI-generated image of Vancouver, by the way, just in case anyone's trying to get into it. I just want to set some baselines about my talk here. I'm not a salesperson. I lead the engineering and business teams for services like Lambda, Step Functions, EventBridge, and there's a long list of services in the serverless compute space. And I would say I'm a Gen AI agnostic right now. It's a tool. It works really, really well for certain use cases. And as part of doing this talk, as I was mentioning, normally I said trends, but this time around what I tried to do was actually build things using the technology I'm talking about. I've been a long-time developer as well. I was a video game developer before I joined AWS 12 years ago. And so this has been a really fun talk, or a fun time actually developing this talk as I got to get back to my roots and actually build things. So this image is the image of Vancouver, generated by the Amazon Nova image client. And the prompt I basically gave it was, give me a picture of the Vancouver skyline with the mountains and the ocean. We do have mountains and the ocean right behind the city. And this is the image it generated. I then looked up this image on Google. And I found that image. Hopefully that's not AI generated either. These days you can't tell. But that's a picture from Air New Zealand's website promoting their flights to Vancouver. So you can see it did a pretty good job. But the interesting fact, just to kind of kick off, and since we're talking about serverless and Gen AI here, is as I was exploring these models more, what I found out is that images are actually one of the easiest things that LLMs can do. What they have a harder time doing is sort of fluid text or fluid pictures, which is basically a video. That's what they find much more challenging to do. Images is on the easier side of things. So anyway, did a really, really good job. Obviously very different from Istanbul, Vancouver, but I'm excited to be here and excited to talk to you folks. So here's the agenda. I am going to talk about serverless. So it's, as I said, this is a learning conference, and I wanted the keynote itself to be more practical and hopefully give you some more useful ideas as you listen to the other speakers behind me who will be getting deeper into some of these topics. I am going to talk about what AWS has to offer, how our serverless technologies, including Bedrock, work together. Then I'm going to talk about a new type of application effectively that has emerged over the last few months, which is agents. Think about microservices in the past, think about your monoliths in the past. I think agents are just a new type of application that LLMs have made possible, and I wanted to share my journey with you as I explored what's possible and different ways of building these agents. And hopefully share some best practices and practical ideas, which will be explored more as I look at the speakers behind me who are going to be following me and talking about this stuff. Okay, so just taking a step back a little bit, 2023 is where I believe where GPT-3 came out, and it just completely captured our hearts and minds about what's possible and what could be possible. I don't think we fully really understood how far Gen AI and the transformer models and their followers are going to get. But on serverless, specifically on Lambda, we didn't see a lot of customers actually using Gen AI initially because a lot of the focus was on training. People were still exploring chatbots, people were still exploring, our enterprises were still trying to figure out how should I end up using Gen AI for my business. So there was a lot of the focus was, say, on the Kubernetes side of things or GPU side of things where customers were actually trying to train their models. And so only with Bedrock, and Bedrock's launched last year, where it became really take off. And if you're not familiar with Amazon Bedrock, I think there are others who are following me who'll be getting more in detail there as well. But Bedrock started with basically the ability to host foundational models, like from Hugging Face and obviously Anthropic. And it's funnily enough, as I got introduced to Bedrock and then used it for this talk as well, it's very much like Lambda. So just as a show of hands in the room here, how many of you folks have used Lambda or familiar with AWS Lambda? Okay, lots of folks. How many folks are familiar with step functions? Actually, quite a few folks. That's awesome. It's about, I'd say, 50%. Well, Bedrock, if you're not familiar with, is very much like Lambda. The main API is an invoke API or a converse API, where you're basically telling or invoking the LLM that you've selected. And it's basically serverless. You're not managing the infrastructure behind the hosting of the LLM or figuring out how to scale that infrastructure yourself. And obviously, all the things synonymous with serverless, like security and safety, are built in. And since the launch of Bedrock, Bedrock has become so much more. We have things like guardrails, we have things like automated reasoning, and we have things like agents, which I'll be getting more into as the talk progresses. And so with the launch of Bedrock, we started seeing customers use more and more infrastructure and started to build actual applications. Remember, training your model is an investment. An investment is money out of your pocket, effectively, right? Like and it becomes a useful investment when it brings useful value back to you. And so it's only through inference that we see useful value from the LLMs. Otherwise, you're pumping electricity and GPUs into training a model. And so that's where we first started seeing customers actually started to build actual real applications once Bedrock was available, and inference has been taking off, and it's been moving so quickly that even in the last few weeks of preparing this talk for you, so many things have changed that I haven't even been able to fully keep up. I will try to get you up to speed on most of the trends as of today, but things are moving fairly quickly here. So initially, what could you do with an LLM? You could ask it a question, do I need car insurance, for example? Now, without any context, without knowing anything about you, the LLM will give you a generic answer. It might even tell you, like, hey, maybe I need this other specific information, but otherwise it's not going to be super useful for you, right? And so very early in 2024, the concept of RAG, or retrieval augmented generation, became super, super useful because, again, if you want to get a more useful answer from the LLM, you need to augment it with some information about yourself, who you are, maybe your age, which country, your state, province you're living in. And then you might get actually a much more useful answer from the LLM, right? You might be able to actually tell you if the model knows the latest about that location or geography, what the car insurance requirements are. You might be able to tell you this thing. And so this is where, I don't have a pointer here, but this is where we first started seeing the melding of infrastructure and LLMs coming together when customers, enterprises, startups actually started building useful applications. Because you're going to need compute, you're going to need databases to be able to do retrieval augmented generation or RAG effectively. And so a quick, I'm sure people have been following these trends, but just to kind of baseline for you today and for the rest of the day for the talk, what is RAG effectively? So it starts with the user's query. So in my case, in the previous example, do I need car insurance? That query is turned into a numerical number, which is called an embedding model. So it's that numerical number or vector is then sent to your knowledge base down there. The knowledge base, it could be a database. It's a set of trained data to provide context to the models. That sent data is sent back into the embedding model or embedded into the model itself, and along with your prompt and or your query and the context, it's sent to the LLM. And the LLM is then able to produce something more useful, something more effective other than generic answers, right? And so the most important things in a RAG pipeline or in a RAG type of query is actually your knowledge base. The better your knowledge base, the more correct your context that you're giving to the LLM, the more likely it is going to come up with more useful results for you. That is the key part of, I guess if I were to say the heart of my talk, it is really just about that context and how you build this context, especially in the case of agents as well. And so again, how do you build your knowledge base? And how can you effectively create that knowledge base became such an important thing for a lot of our customers. So in my example here, for example, your data, data about, again, in the case of my previous example, data about all the different locations which require car insurance or car insurance, could be in S3. You need to basically be able to get that data into an embedding model, which is, again, as I say, a vector data. Store that vector data in some sort of a vector database. AWS has multiple offerings for that. And then be able to retrieve that back into the embedding model when the LLM needs the context. So that's RAG in a very high level thing. I already polled everyone about step functions because I already made you raise your hands about Lambda and step functions. But for a very, very short intro to those who are not familiar with step functions is a serverless orchestrator. It's a workflow as a service. And I'm going to connect this to RAG very quickly, why this is important. So you can do simple things like sequencing tasks. You can do simple things like running tasks in parallel along with the sequence task. You can do some sort of a choice state where you can effectively have if statements or branches in your workflows. You can, a super important part of a workflow, especially with these async systems, when you're calling LLMs, it's always you're waiting for this. So your async is retries or handling. Many of you who've actually dabbled with LLMs might know that you can run out of tokens. There's all kinds of errors that you need to be able to handle. Human in the review, and I'm going to get into this part as well, but workflows also let basically like your application have a human input or humans in the actual process of the workflow, and will be super useful for when you're building agents. At the end of the day, it's also about doing things concurrently at large scale. So we have something like distributed map, which I'll be covering in the next slide, where, well, I might as well go to the next slide, where you'll be able to spin up tens of thousands of Lambda functions in parallel and do really, really, really high throughput compute from it. Again, very quickly, it's a visual builder. It does have a language. It has its own DSL, but it's also a visual builder. So it has a bunch of flow control states, like I mentioned. I was talking about the map state or a map reduce state earlier, or a choice state. It has deep integrations with some of our serverless technologies like Lambda, SNS, SQS, EventBridge, and others. And you can basically call any AWS API without writing any code from step functions visually, especially if you're using the visual builder to build your generative AI applications. And then finally, you can actually call third-party models that are not hosted in Bedrock, like OpenAI or Gemini as well. You can call on-prem APIs or your custom microservices, which are privately hosted inside your VPC, again, without having to write any code and just plug and play things together. So going back to RAG, in my example of, you have files in S3 that you're trying to convert into a knowledge or vector database, this is where we started seeing, again, AWS's serverless infrastructure come into play heavily, because you can actually iterate through all these files, as I said, thousands of files together, using this distributed map state, using AWS SDKs and Lambda to get that data back into Bedrock or get that data into embedding models. So again, concurrency, you get concurrently handle up to 10,000 even without a quota increase. You can batch things, so if you want to make sure you're not using up too many tokens or you're not overwhelming some downstream service while you're creating your knowledge base. At any given time, these are long-running workflows often when you're trying to, for example, doing a daily update or you're trying to build your knowledge base. If anything fails, you can retry anything from any given failure visually. You don't have to rerun your data processing workflow. And finally, you get great observability. So you know exactly what's going on at any time during your knowledge base creation process. And then, again, at the end of the day, you can just create a pipeline. So a RAG pipeline is something which is constantly updating your database, your knowledge base, so it's providing the most up-to-date context for your LLM queries or your agentic applications. And so in this particular case, you have EventBridge scheduler where you can schedule things every minute, every hour, once a day, for example, to just read files out of S3 or wherever your knowledge, the data is that you actually want to put into your knowledge base. Run a workflow. I have a simple workflow here, which is basically looking at documents and creating a knowledge base out of documents. And then you can use the workflow to get that data into any of our AI services, basically. So super simple, super straightforward. And that's where, again, before the rise of agents, we saw customers doing a lot of RAG once they started building these inference applications. So let's now start looking at a more complex query now. So in this particular case, I have a question here which actually needs a lot of context or a lot of steps, for example, where I'm asking what's Amazon's revenue, profit, and margins, and cash flow over on 2025, and I'm asking for a year-over-year trend. And what this means is that now we're talking about much more complex things with agents where we have to now break down the query. And that requires things like planning, where the agent needs to figure out, hey, how do I break down and get this information? It requires memory to remember what it has already looked up. It needs access to tools. For example, rendering tools. Maybe it's a piece of Python code or a Python library to be able to do year-over-year trends or a histogram, for example. And it's going to need to be able to call APIs, perhaps. Maybe this information is not available publicly. Maybe this is an internal system. We're building an internal report. And so this is where we finally see effectively agents coming out. And what agentic systems need is effectively the things I just covered. So they need to be able to plan. They need to be able to have context that they build up. So that's the memory. They need to be able to have tools. And they need to be able to make decisions to see if they're actually working towards the goal, which is satisfying the query that was provided to them. And so effectively what agents are, I'm the anonymous person here. What effectively the agents are a while loop. For those of you who are programmers, it's a while loop calling tools, which is the environment for the agent, until they've achieved their goal. And that's when they break out of the while loop. Right? So that's what it looks like effectively. So the environment is the collection of tools, the knowledge bases that is available to the agent, and the agent in this case is orchestrating these tools to figure out what the right answer is. Right? So the agent can decompose it into steps, call different knowledge bases, call different APIs, be able to observe the results from those APIs, and then evaluate what to do next. Right? That's effectively what an agent is. We're not talking about the Matrix or Agent Smith or anything like that. It's nothing super magical. So let's take a look at a practical agent. And this is one of the agents that are sample agents that one of our solutions architects had created that they shared with me, which is a claims agent. So a claims agent, for example, can use enterprise knowledge base to figure out what the claim documents are. And I've been using this example a fair bit. It can look up open claims from an API. It can look at missing documents, and then it'll be able to notify users or remind users, for example, if they have the missing documents that they need to fill out to get their claims. So that's an example of a single agent basically orchestrating and calling a bunch of APIs to get something useful done, right? And that goes back to the first thing I said to you when I started this talk, that we're seeing a rise of a new type of application, a new type of a microservice, if you want to call it. But it's not a microservice. It's something that orchestrates microservices, kind of like what step functions, for those of you, lots of you raised your hand, kind of like what step functions has been doing for years, but now using LLMs in the middle. Okay, and so I spent some time also looking at some nomenclature. Again, everything is so new, but Anthropic has a wonderful page which talks about the differences between AI workflows and agents. And this is what I distilled from that page as well. So to me, AI workflows are much more like an application. They are more task-oriented. Someone, a human, is involved in actually creating the workflow, creating the checks and balances within the workflow, and help you see what actually needs to happen, and actually make sure and that the task is being achieved. And they're going to be using traditional software, testing software, the development lifecycle models with the AI workflow to be able to deploy and manage it. In the case of an agent, your workflow is an LLM itself. So the LLM itself is deciding what to do next. It is much more fluid. It is much more versatile. So instead of being able to solve one task with an agent, you can solve many tasks with the AI workflow. You can solve many tasks with an agentic workflow. And again, you can combine these agents together. Obviously, the challenge with agents or purely agentic applications is going to be how you test and manage these agents, because now they're doing things that are completely opaque to the user, to the builder. Now, I'm going to start with AI workflows. We'll talk about agents, obviously, as well in a second. But what I found with AI workflows as I started exploring and building my own AI workflow, for example, one AI workflow that I was creating was around just, I have an Audible membership and a Goodreads membership. It's a long commute. Interesting fun fact about Vancouver. Vancouver is the only North American city where there's no highway going into the city. Back in the 60s, people decided that we love our rainforests and we don't want cars in our city. So I have a very long commute. Well, not long in the sense of distance, long in the sense of time. So I listen to a lot of audiobooks. So I built an agent to be able to look through my Audible history, look through my Goodreads account, and generate recommendations for me every time I have to buy a new audiobook as I finish one, right? So that was one of the examples I built. But as I started exploring and building things with agents, again, show of hands, how many of you, and I know a lot of people, very young folks here, how many of you are familiar with enterprise integration patterns? EIP. Some few people. So enterprise integration patterns were all about how you use messaging, event-driven architectures, et cetera, in your architecture, right? And that's what I noticed with the rise of agents and how Anthropic and others are talking about building agents. I see a lot of the same patterns again, like in this case, the fan-out pattern, where my query has multiple steps that could be done in parallel, like synthesizing the data, summarizing the data, extracting things from the data. That can be all done in parallel and then aggregated on the other side and created an output from them, right? So that's an example of a workflow doing its thing, and I'll get into deeper examples with actual code and actual steps in a second. So what are the type of agents that we are seeing in the market? And I just want to cover some of these. So obviously we have real-time agents here. This is where the whole inference of models began, or the initial inference of models began, where you're building chatbots, or you're building basically agents that augment your customer support agents, et cetera, or customer support needs. You have agents which are usually event-driven. So these are the agents that are going to do something, some business process for you specifically, like generating documentation, for example, or doing some sort of analysis on data in an on-demand fashion. And finally, you have your goal-setting agents. And right now, the goal-setting agents, there already are practical goal-setting agents, the one that I described, which are purely agents versus workflows, which are your code generation agents. Again, show of hands, how many of you have used Cursor? Actually, quite a few people. For those who haven't tried Cursor or Klein, I don't have any stocks. I don't think it's a public company. I have no affiliation with Cursor, but if you want to try Amazon QDev, or if you haven't done that, used Amazon QDev or Klein or Cursor, I highly recommend you go try it out when you have a quiet moment. This is effectively using agents to help you code. And this is where these are truly the goal-setting type of agents, and they work wonderfully well for many use cases. So that's one thing. So let's talk about how do we build some of these agents. And so I have three ways of building this, or three ways I explored building these agents. The first one is using Bedrock agents, which is basically agents as a service. That's something as part of the Bedrock family of capabilities. So I'll be talking about that. I use an open source tool, and then again, the open source things are changing so rapidly as well. LangChain was the darling when LLMs came out, but now it's LangGraph. And then we have step functions as an agent as well, specifically for AI workflows. And so I'll be talking about those three. I'll be talking a little bit more about step functions because we're not, as I said, I'm not just talking about Gen AI, I'm also talking about infrastructure with you folks today as well. Okay, so Bedrock Agents is pretty simple. You select your foundational model, you select a set of actions or attach a set of knowledge bases to it, and then provided specific instructions on how you wanted to use those knowledge bases and APIs, and off you go to the races, basically. It's simple, it's easy. So all the orchestration, I talked about step functions and the DSL and the visual builder, you don't need any of those things with Bedrock Agents because they are really designed for specifically one thing, which is to build agents. Step functions is ultimately a full-on workflow service. And any things that are not met with the agent, again, that's where serverless meets agents. And I think this is kind of like the most powerful thing that I have noticed from customers with serverless. With agents and Gen AI, it feels like a second coming of serverless. In the last few years, obviously, there's lots of other ways customers have found to orchestrate and manage infrastructure. Serverless initially, or serverless compute initially, was all about infrastructure and taking in complexity of infrastructure management away. There are many tools now available within AWS, outside of AWS, to help you do that. Things like Fargate on ECS, obviously Kubernetes and the rise of Kubernetes. There's lots of customers betting on Kubernetes to manage their infrastructure. But when it comes to agentic applications, I have found that it is really a second coming again, because serverless from its very roots, or Lambda, if you think of the first serverless service in AWS, which coined the term serverless itself, was the event-driven. It was asynchronous. It was designed to easily work with asynchronous systems. And guess again what LLMs are. They're asynchronous systems. You're waiting for responses. They're not synchronous. If you're synchronously holding connections to these things, you're going to have a hard time scaling your application. And so this is where we found that even with Bedrock Agents, which is a high-level agentic service, if you need tools, if you need to be able to easily augment and provide more information or context to your data or to your APIs, Lambda works perfectly well with agents. And so as I said, the key magic with agents is these action groups. These action groups could be basically APIs to your knowledge base. So you describe the schema of the data that's going to come out and the schema of the API you're going to call, and just call those APIs directly. Or you can, as I said, use your business logic and custom business logic to augment the agent, and it's all Lambda, and you just don't ever have to think about any infrastructure, really. You're just building the agent, and that's kind of like the magic of the whole thing. And then building the agent, again, as I said, you can just use the console and SDK. You create the agent, you deploy it with a version, and then either your users or your custom application, now you obviously don't expose the agent directly to your users. Usually you have an app that has the agent embedded or is generating the queries for the agent that can use directly, or you can trigger it with an event. A classic event-driven architecture on serverless, basically. And so here's an example of using Bedrock Agents and what I mean by action groups actually. So say if you want to build a travel assistant agent, that agent can then use multiple other agents, like for example, a restaurant booking agent, which has again, I don't have a pointer, but which has the first action group, which is actually starting to look like your classic microservice. Right? The first one basically has a Lambda in front of a DynamoDB that is looking up and can do actual table bookings. The second case is a classic, well, I guess you can say it's a microservice as well. There's an API or open search index in front of a S3 bucket to easily give you access to the menu. So the customer, in this particular case, can choose what type of food or they want to order at the table. Similarly, you have a travel booking one that again looks like a classic microservice, where you're going to be able to book your travel, and all of that is being orchestrated by our overall travel assistant. And all of this you can just build to Bedrock Agents. I saw the list of speakers here. I think there's a couple of talks about building actual agents with Bedrock Agents, so those folks will go into more detail, hopefully. And so here's a testimonial where one of our customers took an 80-hour task and were able to automate it down to like minutes using Bedrock Agents, again, writing very minimal code and being able to put things together. So super cool like that. And so this is where the journey actually began for me as I was preparing this talk, because so many things happened over the last 2 or 3 weeks, especially in the agentic space, that I was barely able to keep up. So this is a sort of a later addition to my talk, which is MCP, Model Context Protocol. Both Anthropic and OpenAI and Google have all basically agreed that this is going to be the protocol for how their individual LLMs can talk to third-party tools or APIs. So in this architecture, effectively, the LLM can connect to what's called an MCP server, and the MCP server then goes out and calls the tool, effectively, that the client needs. So instead of the action groups that I was describing as tools to the agent, so I was talking about knowledge bases or API or Lambda functions that you can call in the Bedrock agent. You could use something like MCP and call any REST endpoint, effectively. And so in the classic case, before agents were you had to directly integrate the tools with this thing, and now you have this MCP layer, which is a standard protocol. And so now you can talk to third-party tools that the creators or the software developers of those tools specifically are offering in the format or supporting a protocol that the LLM understands and can call directly. And you can do that with Bedrock agents too. Bedrock has something like the inline SDK, where with using the Bedrock inline SDK, you can describe that MCP server using the SDK itself, and then Bedrock can easily invoke through the inline SDK, go out to the MCP server and call those third-party tools or first-party tools if they are tools that you've built yourself. And you're within your own enterprise or in your own application architecture, you're basically standardizing on MCP as a protocol. It's effectively an HTTP-like protocol, but again, designed for LLMs to be able to invoke it. All right. And again, if you want to play with MCP, I highly, highly recommend that. If you're dabbling with Gen AI, it's a really, really powerful way of building agents, not AI workflows per se, but AI agents, where with that context that you provide, for example, a Lambda function or any microservice, the agents can make really, really smart decisions. And again, going back to the top of my talk, agents are only as good as the context they have. So MCP is a really, really great tool to augment that. Okay, so the open source way of building agents. I already kind of gave it away. LangGraph is the key here. And again, I'm using LangGraph to call the Converse API. The Converse API is effectively the invoke API, similar to the Lambda function inside of Bedrock. And you didn't use actual task service. Again, those of you who are familiar with ECS, you can actually create a service behind a load balancer. That probably is one way, or probably the most popular way of building agents, I'm guessing here. I just use the classic run task API on Fargate. So every single invocation I was kind of treating ECS like a Lambda function. I was creating my agent and deploying my agent, and it was doing the things I needed to do with the context. So that's something you can do yourself. Obviously, in this particular case, you need to do a lot more management. There's a little bit more work to be done in terms of hosting the service and managing the infrastructure. It's not quite as easy as using Lambda, and I'll talk about step functions in a second. But still super useful if you're familiar with open standards and you want to use open tools. AWS supports that, and we're more than happy to support you on your journey in terms of building open source AI models or AI agents as well. And now we're getting into the heart of my talk here, which is really step functions and using AI workflows to actually solve actual tangible problems. Now, with MCP, with the rise of agents, we are seeing, AI agents, the story is only just beginning. It's literally just beginning with AI agents. And at the top of the talk, I told you I'm a Gen AI agnostic. I don't think it's going to end the world and we're all going to be just sipping drinks and just not doing anything while AI does everything for us. I think we're a long way from that. I could be wrong, but some of the most senior engineers, I'm talking about senior principal engineers in my team, are just, in the last few weeks, are awed by what's possible with AI agents right now. So I also don't want to completely underplay it. I do think it's a tool that we need to explore more and learn more. But step functions are using workflows, AI workflows, is what has already been, in the market, and we've seen lots of successes with customers building useful business applications or useful startups in a more traditional way, combining LLMs and powers of agents and tools with workflows together. So it doesn't have to be something a free-for-all where the agent is doing everything for you. you can create certain guardrails or controls and combine traditional SDLC, so software development lifecycle, with agentic applications too. So in this example, I'm building a routing workflow, right? So I want an LLM to see if again, going back to my claims example, the insurance claims example, I wanted to see if some details are missing in a document, so I can get insurance from it or not. And if they're missing, I want to send a notification to a user, and if they're not missing, I want to be able to save the data in some of it. And so I wanted to, for those of you, which is about half the room, that has never seen step functions in action, I wanted to show you that this very, very simple workflow and how easy it is to create this workflow. So I'm using the step functions workflow studio here. I created that choice state to basically check if the data is missing, yes or no. So I'm looking at that missing equals yes case here. And if it's missing, or it's not missing rather, I'm just going to go put item in the DynamoDB table. Again, we have such rich integrations with DynamoDB and step functions that all you have to do is just drag the state. And if it really is missing, I want to send a notification on your event bus or your default event bus saying, yeah, the details are missing, so someone can go look at what's going on here. Similarly, reflection. I'm giving you a simple, I'm not going to go through the whole, I don't have a second GIF here. I'm going to give you a second example here where again, it'll once it has identified a documentation, it's going to be able to go figure out, hey, what are the missing details? And then be able to add those details using the reflection API into your document base. And finally, planning. So be able to remember and be able to say, hey, this is where I want to be able to send a reminder to users or a reminder to people when these documents are missing. You can do planning. And then finally, tool usage. In this example, I'm using the claims example as well. I want to be able to call the get open claims API to be able to see what are the open claims that the user is looking for. And so, if a prompt was set a reminder to the policy holders about their documents and then send them a notification if anything is missing. I'm going to look, these are my tools. So I'm looking at the get open API, open claims API. I'm going to be able to look at policies. I'm going to be able to set reminders. And I have a knowledge base to actually look up what are the missing details from the thing. And so, again, going back to the prompt, what the workflow is going to do is going to execute these tools. The get open claims API, being able to access the knowledge base, being able to set reminders, and be able to generate the missing policy IDs. Right. So what does this workflow look like? It looks like that. So again, without having access to a pointer, and I'll try to point it out here, effectively it's a map state. I talked to you folks about the map state. The map state is going to iterate over the tools, and it's going to build an array at that bottom that it keeps looking at to see, hey, do I need to, and at every step, basically, it's going to say, hey, what are the things I need to do in the LLM? What are the things I'm going to be able to do? It invokes the LLM at the top, and the LLM basically is saying, maybe the LLM will decide to call open claims, maybe able to send the reminder if it's at the end of it. Once it has gone through all these tools and has actually been able to answer the prompt, it'll basically generate the final response and pass it out to the user. That's my workflow at the end of the day. And I'm actually solving a real business problem with this workflow, right? And so, I mean, I showed you the benefits of Bedrock agents. Just to contrast those with step functions. Step functions is much more, you are actually building the app. So it's not specifically designed. So you have, and so while you have a little bit of complexity, and I'll go to the complexities of step functions as well, you also have a lot more flexibility with step functions in terms of models. You can choose models that are not hosted, for example, in Bedrock. It scales super well, obviously, and then the control of scaling is available to you as well. And finally, it's all that visual building experience makes it super easy to kind of plug things together. Now, when I do these talks, the next slide is I also try to leak the roadmap a little bit because I'm obviously trying to get those who come out to listen. I want to give them some advanced foresight as to what's coming out from AWS as well. So I'll be doing that in the next slide. But I wanted to build the context of what we're launching again as well. So some of the things you need to consider if you're building agents with step functions. The initial payload is limited to 256 kilobyte. So if you have a very large prompt, you'd have to feed it in through S3 or DynamoDB. You have some challenges around testing, local because you're building things visually. And then the second bullet point here is a really key one when it comes to LLMs. You all have probably struggled with tokens. You probably have struggled with getting your LLMs. You started returning errors because you're running out of tokens, or have some downstream issues. If your agent is making a lot of calls to some downstream API or database, you need to be able to ensure that you're not running out of resources. So rate control is a super powerful aspect of of these workflows. And unfortunately, right now, you have to go and implement your own custom logic for doing so. But here's the leaks. We are working on rate control as a service, as part of step functions as well. So you will be able to control, and we have great insight into what your token usage is across your LLMs, as well as be able to control downstream APIs or downstream database to make sure that our agent is not overwhelming, anything like that. We'll be giving more observability to distributed map to make sure that you're able to see if you're having thousands of agents or thousands of parallel things that are happening, what is going on, and be able to debug and be able to work through these things. And I'll talk about a little bit more about why that's operationally important in a second. Right now, distributed map in step functions works for S3 only, where we go launching support for any paginated API. So think databases, things returned from the RDS data API, which could be set, any set basically. If you look at think of a classic data structure set, you should be able to iterate through the paginated API using that. So it opens up a whole other universe for RAG pipelines for you without you having to write any custom code. And then finally, this is a big one, and I'm certainly very excited about that, looking at the portfolio of services that I own in AWS. We're going to build a combined Lambda and step functions experience. So think about writing a piece of code in Python or TypeScript. That code uses promises or steps. On your laptop, you'll be able to test, debug it, just like you do test and debug any code you have for your Lambda function. It just runs like any other code. When it runs in Lambda or goes to the Lambda function itself, it'll become a workflow, a durable workflow, and you'll be able to run these workflows for up to a year, and they look like a Lambda function to you, which is super powerful. Those of you know Lambda, a traditional Lambda function can only go for 15 minutes. So we're pretty excited about that. Again, a lot of agents require workflows. Again, I'm not going to go through the whole thing. I know lots of people take pictures. I wanted to summarize the three different ways I have tried to build agents for you. I obviously had lots of help from our solution architects as well. The key thing for you that you have to remember is Bedrock Agents is probably on the most simplest side of things. It's really custom made for building agents. Step Functions is the AWS native way of building things, and it's serverless. Everything everything is handled for you, but you get a lot more flexibility. And then with open source models, you have obviously the complete open source portfolio of things that you could use, but you have to manage and scale these agents yourself. Okay, let's talk about some real practical examples of agents itself and how you can actually combine agents to do interesting things too. So obviously on the left is a single agent. That's kind of like my first query with RAG. You're augmenting that query, telling the agent to do something, it returns something else. Way on the other side is the classic AI agent example that I was giving, or Anthropic is describing, where there is no workflow, the agent is goal-seeking, the LLM is the agent itself and is able to pan. And the classic example of that is Cursor, etc. But if you look at the classic example, I mean, can't use the word classic here since we are still at the very early ages of AI agents as well. If you look at the most popular AI agents on the complex side, they're basically coding IDEs. Right? And so they're not production systems right now. They're systems which are like on a developer's desktop and they're helping you code. Super useful, super powerful, but there's a lot more that needs to still happen before we can say these agents are ready to be trusted or used in production, and that's what I'm going to talk about. So one pattern with agents itself is supervision of agents too. So in this example, there's an agent, and the user can give you many different types of prompts, and the agent decides who's the right next level agent to handle this query. Kind of like in a support call as well, like the support person is able to route, tier 1 support is able to route you to the right resource to help figure out how to solve your problem. The second type of agents I want to talk about is async agents. And I'm actually going to put A2A in here as well. This is the part where I just ran out of time, to be really honest with you, to really get into it. A2A, I think, is agent to agent. A2A stands for that, is an agent to agent protocol that Google just launched, I think, last week. And they've launched it with 50 other partners. And this is basically something that builds on top of MCP. So remember, MCP was the Model Context Protocol for tools. So a single agent to talk to its tools. This is a protocol for agents to talk to other agents. And actually, there was, just yesterday, I was reading an article. I was enjoying Istanbul, but I was reading an article about someone using EventBridge, which is the other service I own. It's a serverless event bus, and building A2A using EventBridge and events, so that agents can talk to each other asynchronously using events. And this is an example that I have really at the highest level where you have a hierarchy of agents, but instead of synchronously connecting them together, you can send events that are from the supervisor agent out, and those events and those agents come back and they store their data in S3, and once the results are there and the agent is happy with the goal that is achieved, it can go back to the user. But again, A2A is something that we'll be exploring over the next little while as well. Okay, now I kind of teased the human in the loop part. And so I'm trying to get to, so say if you are ready to build your first AI workflow, or you're ready to build your first AI agent, how do you get it quote unquote production ready? And so the first step when it comes to these things outside of like your developer IDEs is going to be, hey, how are these tools going to be safe? How do I know that it's actually solving my customer's problem? It's not actually going to take my customer into a different direction. And so having a human in the loop becomes super powerful with these, especially in the first type of agents where I was talking about real-time agents where you're directly interacting with your customers. You're able to, the human is able to then validate the responses from the AI. It is a final sort of gate to make sure that whatever your final end user or customer is receiving is the right thing, for example. So super, super, super powerful pattern with AI workflows. And so here's an example of that. Say your AI is about to publish a blog, and you want to make sure the blog is good. What the workflow could do is basically send the blog, just like like an author would publish the blog to the editor first, to a human. The human gets a token. They don't need to see the token, but they get a token from this workflow. They can review the blog or what the AI has generated, make sure it's good, make sure the content is valid, just like a real editor would do, while the workflow waits. If the editor says yes, then they send the token back, and then the workflow says it's approved, and it basically publishes the blog. That's the human in the loop workflow. Again, this capability has existed in step functions pretty much from its inception, but now with the rise of AI workflows, it's become much more powerful and much more popular now as well. Getting to the end, I know I've given you guys folks a lot of these things. I wanted to share a couple of, again, real practical uses, practical considerations of building your AI agentic, whether they're workflows or fully AI agents, your agentic applications. The main thing is context. How do you know that you've actually solved the user's problem? How do you know the response that you're giving back to the user's prompt is a correct response? That is a big question. So I'll tell you something, again, that we are ourselves grappling with as we're building agents. We are building agents too. So giving, for example, right now the Lambda team and the EventBridge teams, for example, when you go to our console, we are working on an agent to basically help guide the developers into solving the problem they want. Our first question would be, hey, if the agent actually publishes an IAM or tells the user to use this IAM policy, how do we know that IAM policy is the correct one? I can't put a human in the loop here, because imagine having a human validate every single IAM response. We get, I don't know, hundreds of thousands of requests in the console per second, in the Lambda console per second. Same thing with EventBridge. They're some of the most popular consoles in AWS. I can't have a human in the loop. So how do we know it's correct? And so, again, building and evaluating your context, our metrics around the context, is the key thing we are grappling with. As far as I'm giving this talk today, there is no framework out there which says this is how you evaluate the context, or this is how you evaluate that this is the correct response. For ourselves right now, a lot of the agents are still experimental. Even if you're exposing them to customers, we're telling them they're experimental. That's the way we're working with it. But this is a key problem to solve as you work on your AI workflows or AI agents, basically. Lastly, going back to infrastructure. Just like every other application type, there are infrastructure concerns here as well, even if you're using serverless, right? Because, yeah, your compute is taken care of, and the scaling of your workflows and scaling of your Lambda functions you don't have to worry about. But you have to worry about other things like your downstream resources. You have to worry about network congestion or database congestion if your knowledge base is overcome. That's where I was talking about the rate control and resource management techniques earlier on in the talk as well. So you'll see many of these things you will have to basically, you've done with your microservices, your traditional event-driven or API-based microservices, they still apply to your AI-based microservices as well. Anyway, final thoughts on this thing. Again, going back to the very first thing I said about AI, or generative AI, it's a tool. It's a tool that is, it's not a solution for every single thing. So use it carefully. In many cases, a good RAG pipeline with good context to a single LLM call can actually solve many of your problems, to be really honest with you. Agents are super powerful. I've talked about it, but really many problems that we face today can easily be solved and managed through a RAG pipeline. And finally, focusing on the context and making the context better over time and measuring specifically how well the context is for the query is the key thing that you need to go figure out. Thank you, everyone. Any questions?
If there is any questions, we will get some questions.
Thank you for the keynote. I was wondering, the step functions diagram you showed, there was a map state. What was it mapping over? Is it mapping over the data or the tools you mentioned?
Sorry, could you repeat the question again?
There was a map state, right, in the step function diagram you showed.
Let's go back to that. I'm missing, you said the next state?
There was a map state.
Oh, yes, map state, correct.
And it was mapping over the data, or is it mapping over the tools you mentioned, like the agent tools? Actually
the funny thing about the map state is every single step in the map, so I think of every branch in the map, is a workflow itself. So you can make it anything you want it to be. It could be APIs, it could be Lambda functions, it could be calls to a database, it could be anything you actually want it to be. It literally is a nested workflow. So the map state is basically a collection of nested workflows. It's the same workflow running n times. So there's the outer workflow, which is kind of controlling your whole app, and then there's the inner, what's happening inside a map is just like a repeated workflow. So it could be super versatile. It could literally be anything you want it to be.
I see, thank you.
Any more questions? Goran.
Hi, I would like to know what do you actually use today, let's say as a customer of AI, like in AWS? Do you have any actual usage of AI in anything other than like support services, chats, and stuff like that?
Of course. So, well, firstly, like as I said, since the release of Q Developer, if you haven't seen Q Developer CLI or Q CLI, the usage in my look, I lead an organization of about, I think, 500 some engineers. The engineering usage has gone through the roof now. Like we are seeing tons and tons of actual development happening using Q Developer specifically. The other use is basically as I mentioned, we ourselves are building agents right now. I mentioned the agents in the console. I'm talking about agents in our tooling as well, like in the IDE itself that we want to build. So some of the usage is actually coming. It's just around the corner. We're actually trying it out with some of our partners or our beta users right now. But the biggest use is actually in development now. And that is also just recently, I would say, over the last 8 to 10 weeks. Since Q Developer has come out, it has exploded. Like we are seeing tons and tons of use there, especially in developers trying to understand code, like understand what the code is doing, say a code inside of how Lambda is built, all the way to actually generating new code. That's where I see the most usage.
Any more questions? Like you can always find Usman throughout the day, and yeah, for more chatting. Thank you, Usman. It was our pleasure to have you here. And
thank you, folks.
This is like a thank you gift.
Oh, thank you. Thank you, everyone.